Okay, so today we will discuss the valuation stage of decision making, a neuroeconomics model of valuation process. As I suggested during the last lectures, neuroeconomics focuses on the decision making process. And we try to understand during this course the neurobiological mechanisms of decision making. So, as you remember, neuroeconomics suggests that decision making process can be divided in few stages. So first, the problem is somehow represented in the brain. So next, brain evaluates the available options. At the next stage, we select an action, and finally, we evaluate the result of our action. So based on the evaluation of our action, we learn and we can update values and we can modify previous stages of the decision making. So, valuation process is a key process in decision making. Imagine that you have a motivation to drink and you have a specific motivational state that urge you to select between available options. For example, you can select between different types of different brands of cola. So you make a decision, you select the particular brand, you drink it, you experience certain pleasure. Based on your experience, you modify values for this brand. So for neuroeconomics, the stage of valuation is particularly important. If you can decode values from the brain activity, you actually can predict decision of the decision maker. So today we will focus on this stage and we will try to understand how nervous system codes our preferences, codes values in certain neuronal networks. So of course our decisions are normally very complicated. So at each moment we assign values to various options, and neuroeconomics cannot answer and give hints about the neuronal process underlying very complex decisions. But at the moment, neuroeconomics focuses on more simplified cases. For example, when you choose between two options. So for example, you choose between an apple and a cake. So we can, for example, use a normative theory, so-called maximization theory, suggesting that when we select between two options, we select the option with the highest value. For example, when we select between apple and a cake, we select the option that has highest value for us. But how to estimate values? So of course we can, for example, measure values as price. For example, apple can cost €1, cake can cost €2, but definitely this is a not objective measure of value, because if you're on a diet, cake can have a very low value for you. If you're, for example, very rich, $2 cannot be a real value. It can be nothing for you. So values are very subjective. We can't really measure them using, for example, prices. That's why decision theory suggests to use utility. Utility is a measure of the desirability of the consequences of our actions. So we can assign utility to two options. For example, utility X and utility Y. According to the rule of maximization, we select the option with the highest utility. So how to measure utility? And in this case, actually decision theory faces a serious problem. How to measure utility using numerical numbers? How can you measure your preferences, your expected values of classic music? How can you measure your values using numerical numbers? For example, for your preferences to Dostoevsky, to cheese, to Coca-Cola. Actually, we cannot really measure using numerical numbers our preferences. That's why decision-making theory almost exclusively use ordinal utility. So ordinal utility is a relative utility. So we can sort, we can order our preferences from the worst to the best choice. So this is a very simple way to address utility. So basically economics almost exclusively use ordinal utility theory, suggesting that we have to use relative utilities when we make decisions. There is a famous joke when one economist meets another one on the street and asks him, "How's your wife?" So the answer of the second economist is, okay, relative to what? So economists do not use absolute numbers, they use relative numbers. So in this case, you would assign relative utility to different conditions. So my wife, for example, is in a better condition than my aunt, and my aunt in a better condition than my cat. So modern economics almost exclusively used relative values because we cannot measure directly the numerical level of our preferences. It would be wonderful if we can measure directly utility. So in this case, we could use cardinal utility. If we would be able to do it, we can assign particular numbers to different choices, to different conditions, and we can simply compare these numbers. So if condition A has a higher utility than condition B, I would select condition A. If condition A has a higher utility than condition C, I would still select condition A. But in reality, we cannot really directly measure utility. Once again, how can we measure directly with a numerical number our preferences to Mozart? So actually, neuroeconomics give us a possibility to measure utility directly, to use cardinal utility. I will explain it in a few moments. So let's now summarize a bit some definitions of neuroeconomics and economics. So value is an objective measure. For example, a book can have a price, $122, but values are subjective. So if you're a very rich person, $100 doesn't mean anything for you. If you're a really poor person, this object has a huge value for you. That's why in economics, utility, idea of utility is introduced. Utility is a subjective measure of values that is individual for each person. In neuroeconomics, we offer the new definition of utility. So subjective value is simply an average rate of activity of our neurons in certain neuronal populations. So for neuroeconomics, our values, our subjective values, are simply activities of our neurons in the brain. So perhaps it's quite difficult to digest this theory, but I will try to convince you that this theory works quite well. So for neuroeconomists, values are simply average firing rates of our neurons in certain brain areas. For example, in ventral striatum, and we will discuss ventral striatum a lot today. So once again, the neuroeconomics theorem suggests that subjective values are average firing rates of population of neurons coding our preferences, and nothing more. So from neurobiological perspective, object has a subjective value if it activates certain neurons. And it has some value if this object is a reward or punishment. So I introduce now these terms reward and punishment for some reasons. By these two terms, we connect the idea of values, of utility, very economic ideas, to the whole range of neuroscience literature investigating rewards and punishment. I will try to explain you this idea in a few slides. So let's make a look to this object. This object has certain value. For example, if you are hungry, this object has a value for you. If you are not hungry, perhaps this object has no value. So here, this object, from biological perspective, has a value only in the case if you would work to collect this object. So if this object doesn't have value for you from neurobiological perspective, you will not work to collect this object. You will simply ignore it. So for neurobiologists, those objects have values if person or an animal will work to collect these objects. So in these famous cases, pigeons will even play ping pong to collect objects. For neuroscientists, the indication of value is an temptation of the animal or of the person to work to collect this object, or actually to work to avoid this object in case of punishment. So how can we measure values, subjective values of animals? We can use a very famous device, so-called Skinner box. In this box, a rat can press a lever and get food. So basically, this rat will only press the lever to collect something that is rewarding, that has some value. So we can actually check preferences of this rat by studying the frequencies and the number of lever presses per minute. This animal will work to collect food, and the activity of this animal will indicate the subjective value of this food. This animal will also work to avoid, for example, painful foot shock, because the electrical foot shock can be applied to the metallic grid in this chamber. So animal will press the lever to avoid foot shock, to avoid something that has negative values. So this is an example of a real experiment. So for example, in this case, a rat can see a signal, for example, a red light, and press the button to collect food. So frequency and speed of animal response indicate the subjective value of rewards. So we can measure our values behaviorally here. And there is an outstanding literature in neuroscience trying to explain neurobiological mechanisms of processing of their rewards and punishments. So famous experiments conducted more than 50 years ago showed that animal will work to stimulate, to obtain a stimulation of their own brain. So if certain electrodes are encoded to particular areas of the brain, animal will press the lever to electrically stimulate own brain, the particular neuronal populations in the brain. So this animal doesn't need food, doesn't need drink. It will directly stimulate own brain. And if we will make a look to the actual results of this experiment, there's hundreds of bar presses during the experiment. This animal will stimulate and stimulate and stimulate own brain. It will make breaks only when the stimulator is turned off. If the stimulator is switched on, this animal continues to stimulate own brain and stimulate it for hours. This animal will die from starvation. It will ignore food, it will ignore drinks, it will just stimulate own brain till the end when this animal will be dead. So we can directly access reward centers of the brain using the stimulation of particular neuronal populations. So actually, from neuroeconomics perspective, an object has a value, or an option has a value, if this option stimulates particular neuronal populations. So our values are simply firing rates of certain neurons in our brain. We can directly stimulate these regions, and we can directly stimulate, emulate reward values. So in this video, you see a rat that simply self-stimulate and self-stimulate own brain. This animal will ignore food, will ignore drinks. So with electrical stimulation, this animal will directly stimulate neurons that code values. So this animal, by stimulation, kind of emulate values in the brain. So our values are nothing more than the activity of certain neurons in the brain. So in very unique situations, we can investigate the same self-stimulation effects in humans. So some patients get electrodes implanted to certain brain areas for medical reasons. So there are famous studies showing that when these patients have an access to the electrical stimulation of some brain areas, for example, of nucleus accumbens indicated here by yellow color. In popular literature, this region is called reward centers, pleasure center. We will come back to this area during this lecture. But if patients have an opportunity to stimulate, self-stimulate this region, they will do it for hours. So these people will stimulate and stimulate themselves. Some patients ignore own hygiene, relatives, family. They simply self-stimulate and stimulate and stimulate own brain. So they can evoke reward values directly by the activation of certain neurons in the brain. So our values are simply encoded in the activity of our neurons in certain brain areas. Particularly important brain areas for valuation process are related to dopamine. So this neurotransmitter is produced deeply in the brain and mainly in two areas, ventral tegmentum area and substantia nigra. So these two regions produce a lot of dopamine, and this dopamine is distributed around the brain. So here on this scheme, on the left side, you see areas that get a lot of dopamine. And pay attention to one of these areas, nucleus accumbens. The nucleus accumbens, this pleasure area, is a key area for valuation process. So this area actually encodes our expected values during the decision making. So let's discuss activity of the nucleus accumbens and the role of dopamine system in the valuation process. If we block receptors for dopamine, if brain is not sensitive for dopamine anymore, it prevents self-stimulation. You see on this slide the effect of the blockade of dopamine. You see that animal stops to self-stimulate if you block receptors for dopamine. So dopamine is a key, very important neurotransmitter for self-stimulation, for emulation of subjective values. So, as you will see today, dopamine plays a critical role in the valuation of available options and also in learning. So it is engaged into the evaluation of the outcomes of our decisions. So as you will see, this dopamine system, particularly the ventral striatum on nucleus accumbens, is a critical region for decision making, for valuation stage of decision making.